second like bell thing if like a lot of people forget?
No, they normally do it, but people are out, so it could just be they're confused. All right, a missile is accelerating.
Can we please like make that
at a rate
That was the biggest class, okay.
of
a missile is accelerating towards McCokewood.
Yeah.
4t meters per second squared from a position at rest in a silo 750 meters below ground.
Towards North
How high
Korea.
above the ground will the missile be after 6 seconds?
Or keep positive and then what's the sort of second?
Well, yeah, we'll get to that. We're not there yet, right? We'll talk about that when we get there. Cross that bridge when we get there. So good that that's important to think that way, though. So, our question that we want to answer: how high above the ground will the missile be? How high is a what?
Position.
A position. So we need to come up with a position at what time? 6 seconds, right? So we need to come up with a position function probably first, right, before we can then come up with its position at 6 seconds. So what other information do we have? The missile is accelerating at a rate of 4t meters per second squared, and it has from its position at rest in a silo 750 meters below ground. Okay, so we have an acceleration, don't we? A of t equals 4t. Not 40, 4t. All right? So, to get position from acceleration, what do we do? Integrate. All right. So we integrate 4t with respect to t. And the integral of 4t is going to be, well, it's t to the 1, right? So what do we do? T to the 1 becomes t to the 2, and we put that 4 over the 2 exponent that we got there, and then we'll put plus c. This new thing, is that the position? That is velocity. So we're going to say velocity of t is then 4 halves t squared plus c. I guess I should have just written 2 t squared plus c there. All right, great. Now what should we do?
Do it again.
We can do it again. I'd recommend finding c first, though. We need to find the c value first. You can do it again. You can, okay? But it's going to be more difficult then to figure out what that c value is. You're going to have 2 c values. It's going to be messy. So, all right, great. So we need some information about the velocity. What are we told about the velocity?
It's 0 at negative. Wait.
At 0, the velocity is 0.
Yeah.
At time t equals 0,
Yeah.
the velocity is 0. Where do you see that? I don't see at time t equals 0 the velocity is 0 here.
Well,
Yes, at rest.
Yeah.
That means the velocity is 0. If you are at rest, I'm going to highlight this here. Maybe in a color. Do I have my red? What's that?
The silo is below ground?
Yes, exactly right. The silo is in the ground. It's a missile silo. It is typically in the ground. That's the idea. Oh, no. It's like a tube in the ground. It goes, out of the ground.
I know. That's crazy to think. I will be sitting in AP Physics on Monday.
We're going to have this.
Yep.
Yeah.
We're going to get to that. But it does matter, actually, yes. So, V of t equals 0. So that means for this, at time t equals 0, right? So we're going to plug in 0 here and set this, so it's 0 equals 2 times 0 squared plus c. So c is 0, yeah. So our velocity with this, our particular velocity for this situation is 2t squared. Exactly. Do not forget those c's when you are integrating. That's another big thing for tomorrow, folks. All right, don't forget when you integrate, you need to put that plus c at the end. All right, we got the velocity, and we found our c value. Now, Mac.
And now you do it again.
Now we want to integrate. That's right. So we're going to integrate. I'm going to do it up here just to save space. So integrate 2t squared dt. T squared becomes t to the third, and it'll be 2 over 3 then up front plus c. So this is now our position. I'm going to use s of t here. All right, we need to find a c value for this too. We need to find this c value. What do we know about do we know anything about our position?
Yes. At x equals 0, the position is 750 meters below ground.
Yes, at time t equals 0, our position is negative 750 meters below ground. So that means s, what number goes in for replaces s of t?
Negative.
I'd say negative 750 because we're underground there. And then 2/3 times 0 cubed plus c. So c is just going to be negative 750. All right, great. So our position function 2/3 t cubed minus 750. So, and there's our answer. No, that's not our answer. What are we supposed to do?
Plug it in,
How high above the ground, what's the position after 6 seconds? We're going to plug in 6. So S of 6. All right. So let's see
Doesn't
here.
seem correct. Remember?
Yes.
Alright, so it isn't a block grid.
I got a negative number twice.
That's what I said.
After 6 seconds, a missile.
You imagine the
I guess-
initial, kind of
Velocity,
accelerate,
kinda
it
like
takes
a
some time,
slow-
exactly, but then once it's going, whoosh.
It has to burn the fuel.
Right. So yes, when we plug this in here, we end up with negative 606 meters, right? Don't forget
Something that would
meters.
really throw me off.
So
on,
it's
like,
still
that.
subterranean.
Makes sense, though. I mean, if you look at your equation makes sense. So it makes sense.
Right. You got to trust the math. Sure. Stop thinking logically. And of course, you got to understand. I mean, this is a made-up problem. So would a missile really take 6 seconds? I don't know.
It's a part that says
Right.
it takes 6 seconds to move 144 feet.
Right. Right. You got to understand when the missile first, I guess starts
It's so weird.
blasting. It's got to be able to just hold up its own weight, and then it starts to push and go more. So, and eventually it goes really fast. That's right. Yeah. Exactly. All right, let me give you one more here to try, and then we'll get into the area under a curve and stuff like that. All right, here we go. Here's a bit of a contextual kind of problem. The motion of a grizzly bear stalking its prey.
Stalking Leonardo DiCaprio.
Yeah, exactly. Yeah, stalking Leonardo DiCaprio. Stalking its prey, walking left and right, of a fixed point. That's Leonardo DiCaprio, the fixed point. All right, so the motion of a grizzly bear stalking its prey, walking left and right of a fixed point in feet per second. So feet per second, those units indicate we're talking about its velocity. Okay, can be modeled by the motion of a particle moving left and right along the x-axis. That's the problem with context, is that sometimes it can get a little cumbersome, but anyway. According to the acceleration equation, so we're gonna look at we're given the acceleration equation. According to the acceleration equation, a of t equals negative sine of t minus 1/3. Yeah. All right. If the bear's velocity is 1 foot per second when t equals 0, dot dot dot.
Oh, it's gonna be an ABC problem, isn't it?
Yes. Easy as 1, 2, 3. Simple as do, re, mi. ABC. 1, 2, 3. Baby, you and me, girl. Find the velocity equation. How fast was the bear traveling at t equals 7? And then letter C, in what direction is the bear traveling Good question.
How fast would generally?
I think speed. Yeah. In what direction? So yeah. I'll clarify that. How fast is the bear traveling at time t equals 7? In what direction is the bear traveling at t equals 5? Okay. So I want you to answer all 3 of those using the given information. So find the velocity equation. Find how fast, that is the speed that the bear was traveling at time t equals 7, using correct units, and in what direction is the bear traveling at time t equals 5. All right? So I'm going to let you guys go ahead and start tackling that. And then I will go prepare the copies for our next adventure.
This is a calculator.
Yeah, you can use your calculator for this. You're going to need to. Yeah, you'll need to use your calculator.
Why would you need a calculator?
I don't know. I just wanted to use it to make it easy.
Oh, I see why.
For C, I think.
No, you'll need it to come. You want like decimals to start with.
Say again?
You want like decimal values.
Yes, nearest 3 decimals, please.
Mr. Wood?
Yes.
Do you have like a way to remember how to
Sine and cosine, all that.
Yes, if you know your sine and cosine derivatives,
Yeah,
then
but-
you just go back. That's
Now,
what you do.
now we get them mixed up.
So I always memorize, I just have the derivatives down. So I would say to myself, okay, derivative of sine is cosine. And then I saw here, okay, I've got sine. So I'm like, okay, no. The derivative of cosine is negative sine. Oh, I've got negative sine, so cosine is its integral. That's how I did it. I memorized the derivatives, and I just go backwards.
I had to memorize it, now I just don't, because they just mix together now.
Well, I understand. But that's what I suggest you do. My suggestion: memorize the derivatives, have those down, and then just go backwards. Just go backwards. Like I would recite it in my mind. Okay, derivative of sine is cosine. I have sine. I need to go backwards too. So yeah, just go from there. That's what you have to do.
Yeah, that's where you said you gotta go to your
Load it back up.
That was me yesterday, I'm like,
What?
Are you in, ready?
No.
Ryan, are you going to volunteer today at the elementary school?
Let's see, is this when, the bear velocity is 1 feet per second, when
I practice. I need to talk to you about that.
T is 0. Yeah, let's see if T is
What direction is the bear traveling in? This should be
because, see, like, this feet per second,
Boy.
one up there, so like, it's the bear
Dead.
velocity is 1 feet per second.
So,
That is V of T. V is T and T is
Cosine.
0. I got 1.57. You did multiply.
So the direction, since it's negative, it would be traveling left? Jeff, right?
1.59. Well, you can round or chunk it, so it's 1.594.
Now we'll find the rate of evolution of the bear. Well, we're gonna do an English today. We're gonna finish our. Have you guys finished your? Yeah.
Oh, that's right.
You guys not? No, because we spent like
Right, so we used to.
half the class talking about.
Yeah.
We don't debate long. We debated so much yesterday. Yeah.
Now, that's what you're trying to find.
The only group that debated really was like my group. No, it's because I engaged everybody. We debated like crazy yesterday. Like that. Oh, we got a paper. No, wait. I think we're just gonna watch the movie. To be honest with you. I hope we do. That's what I asked my blue. Like, we expected some film. Oh, I have JDB next semester too. What? I have it for 101. I can sign up for. I have to switch from Chem to film stuff. Limited space. Oh, no, you don't. It's freaking high school, dude.
One third X is
Yeah.
2/3 X squared.
I've had. I will not have had a single female teacher this entire year. That's pretty awesome. You have a spank. That doesn't count.
I've got cosine.
Because that's like an 8.
I see dream of.
That's a cool thing about high school. There's so many more guy teachers. Way higher in high school. Because guys are just like, I'm not dealing with elementary schoolers, but I'll deal with like grown ass, like actual people. Oh no!
I have one place with Y buddies. They're like coworkers, pretty much.
They are coworkers.
Yeah.
Oh,
For 1.5, I mean, close enough.
These are the bomb.
Right?
And then that's done for that time.
Your hair is cute, Joey.
Dang, you're pretty cute too.
Thanks. The fuck?
You look really cute on a tree.
Yeah,
the women's tree.
One.
Bro. The tree's still there. No, that's great. Negative one. It tastes really weird.
It's good.
Just to the left. Negative 1.383. Negative 1.3.
Dude, I sack the punter every time.
How'd I do it?
someone punts.
That's the point of the question.
Okay, what's on a 5? Minus 5 over 3.
We did one, and that's
You just
one
asked me
of the
about-
time we're changing.
No, I said, yeah, A. What did you get?
And what was
C value for A?
Oh, I thought you meant like C as in
When you
letter
get C,
C.
how'd you get C?
Having appointments.
What C are you talking about?
When
No,
we-
A.
when we
No,
did-
no,
hold on. C value.
C value of A.
That's 0.
Something you do, that's why.
Okay, now like CC, like the real C.
So, yeah.
Negative
We just
1.383.
integrated for no reason.
How?
That's what I got.
How'd you
You
do
know what
it?
you got?
What?
Negative 1 point something. For C.
That's what I got.
Yeah.
For C, I got negative 1.95.
I got negative 1.383. Yeah.
Oh, wait.
Fuck you then.
Calculator.
Did-
Use your calculator. Use your calculator. Help you out.
I
Okay?
did.
Because you're right, you can't do it without it.
You could answer like someone asked me what I got.
Without it,
Like,
yeah.
you got that, and I'm like, what?
All right, folks.
Alright.
We're okay. Can I do letter A?
You said dirty things on the video while you were going.
Great. All right, so the integral of acceleration is going to yield the velocity. That's what we want, right? So we're going to integrate acceleration here. So the integral of negative sine t minus 1/3 dt. That yields. Integral of negative sine is cosine of t. Integral of minus 1/3, minus 1/3, yeah, t plus c. So that's your velocity then. They're going like,
Wait,
walking
isn't it
left
negative-
and right.
Shouldn't it be negative cosine?
they're kind of like weaving back and forth to their prey.
Oh, that's, I don't know. The whole time.
They'll stalk prey too, I think. I mean, maybe. I don't know. Probably. You know,
Leo.
Leo DiCaprio got stalked. I'm pretty sure. Don't watch it.
What?
Donovan disagrees. Donovan liked that movie a lot.
Called The Revenant. Or dude gets retired there.
My sister, my dad took my sister to watch Everest, and my sister like freaked out
It's scary.
when some guy in the movie threw up blood, and my sister was like, ew.
Okay, so now what? Is that it?
Yeah, we're done.
What do we still have to do? Well, we're not done with even A yet. We have to figure out what C is. So what information can we use to find the value of C?
You have a point.
The velocity is,
At 0.
the bear's velocity is 1, add time t equals 0. So we can say 1 equals cosine of 0 minus 1/3 times 0 plus C.
When you said bear's velocity, I think
I said velocity.
Bear like flying.
Alright, so cosine of 0 is 1. So C equals 0. That's nice. So the velocity equation is just cosine t minus 1/3 t. There's the velocity equation. All right, questions on that? Moving on. Okay, letter B. How fast was the bear traveling at time t equals 7? What do we do with that? How do we find that?
Oh wait, I think you take.
Shh, guys, listen up. We're going over this. This is going to be on tomorrow's quiz. Some of you guys are still not, you need to pay attention for tomorrow. We have one more quiz still. Don't shut down just yet. Time's not over. Plug in 7. That's right. V of 7 equals cosine 7 minus 1/3 times 7. All right. So this is where we'll need a calculator, because no one here can mentally figure out what cosine, well, maybe some can, I don't want to say yay or nay there. And remember, we're set in degrees, so cosine of 7 minus 7 divided by 3, 7/3, that's what 1/3 times 7 is. Negative. That's all we need to worry about. Well, sorry, not in this one. Sorry, the next one we'll worry about. This one we need to worry about, so, nope, should be set in radians. It's approximately negative 1.579 is the velocity there, and that would be in what units? Feet per second. Is our answer, though, negative 1.579? No. The speed, how fast, we're talking about speed, we think here. I think that's the correct interpretation there. 1.579 feet per second. It will be more clear about whether I'm asking for just, velocity or speed. And if you still are unclear about it, I will, be able to clarify on the quiz tomorrow. But it should be clear. Velocity will be negative because it has that direction aspect to it. Speed, always positive. All right. So, letter C, in what direction is the bear traveling at time t equals 5? Okay, what tells us about the direction of the motion? A velocity, specifically if the velocity is either positive or negative, right, so we'll just plug in v of 5 equals, so let's see here, cosine 5 minus 5/3. So it's negative, approximately negative 1.383, so that means the bear is traveling to the what?
To the left.
Is traveling to the left.
Sounds
Okay.
so weird when we put it in terms of a bear. Bear walking in a
Is that a
straight line.
book problem?
I have no idea.
Where'd you get it?
I don't know. I'm not sure. Yeah, past.
No, I was like, where'd you like?
Bear is traveling to the left, and if we want to justify that, because we can justify it, right? Because its velocity is negative. True. The bear's velocity is negative
Because only rotate if you're living on the wrist.
at t equals 5. That's true. I will follow my own. Yes.
Put it on roll.
It would be correct there, grammatic. Yes, it would be fine. It would refer back to the bear. Yes. Yeah. 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 I see what you're saying. But yes, I think that should be fine. Okay. All right. So there's that. Any questions on that? So this is the point at which we say, this is what we cover for the quiz. Okay. Particle motion and integration. So we're good there? All right. What I'm passing out now will not be on tomorrow's quiz.
Why not?
But it will be, we're moving into.
Do that means you don't have to do it.
Now we can justify those problems.
You don't have to do it.
What do you think to have a large amount of electricity was put into a calculator?
I think it would depend on how much, the number of, like, amount of amps, and then the, probably melt your calculator.
Yeah.
Or it would, probably smoke.
Freshly your counter gauge was calculated to make your monster to electrify. Electrocute, and didn't think anything bad happened.
Why did Mr. Monster do it then?
I don't know.
Mr. Monster, at the end of every year, always asks for, like, donations of things for him to just, like, hook up to, like,
okay, got it.
no.
Like, he did a hot dog once.
And Gary ate it?
Oh, God. I'd try it. It's still food.
No, it was, like, green.
Oh.
It was so gross. You
I don't
had
know
no
about green hot
idea.
dogs. I don't know about green hot dogs. Okay. All right. Oh, I gave you one. So, one of the big applications of integration we will discover here shortly is using integration to also find the area under a curve. Just like the derivative has a kind of main concept, the main reason we were using the derivative was to find the rate of change of something, right? If you want to find the rate of change of a function, you take the derivative of that function, that gives you its rate of change. And in another sense, in a similar sense, we have then, if we have a function and we graph it, we can find the area under it for a certain interval using its integral. Okay? So, we're going to look at area under a curve right now, we're going to start very basically with stuff that we can do with just geometry, and then we'll move into how we're going to then apply calculus to it. So, yeah.
So, is this just the area under a curve to the x-axis?
Yes, we are using the x-axis as a boundary, so that's a good point. Okay, yeah, so when I say the area under the curve, that means we need to come up with boundary lines here, right? Because there's like all this kind of crazy stuff going on here. So the area under the curve, that means, so here's the curve. Okay, it's really the area between the curve and the x-axis. So the curve will be one boundary. Okay, the x-axis is also a boundary. And then we still need some more boundaries though, right? Well, we want to find the area under the curve from 0 to 4. So here's 0 right there, and then to 4 right here. And so that means this is also a boundary, and this is also a boundary right there. The vertical lines at 0 and 4, those are boundaries. So we have 4 boundaries. Sometimes we'll have more than that, but here we have 4 boundaries. So to find the area then under this curve, that is the area between the x-axis and the curve, from 0 to 4, what can we do? What's the shape that we've created here?
A rectangle.
It's a rectangle, okay, or a box, sure. What is the area formula for a rectangle or box? Length times width. So what is the length of this box?
4.
Okay, 3 or 4, right, doesn't really matter, and then the corresponding width is the other measure, either the 3 or the 4, depending on what you said first. Yeah, it's just going to be 3 times 4. So that means we can say the area underneath this curve is 12 square units, right? All right? So that's pretty straightforward. So again, and all we're doing here is we're looking into the new section. This will not be on tomorrow's quiz, but it will be, obviously future stuff that we'll be covering. We're finding the area underneath the curve, okay? So we're going to continue on with this then. We're looking at the second one now. All right, so now let's look at this one. All right, here's our curve now. So that's one of our boundaries. Again, when we say the area under the curve, we're really saying the area between the curve and the x-axis. So it's like, actually, I guess I could have shaded this in here so you get a better idea of kind of like the area we were talking about. Okay. Likewise here, we have a boundary here. And you don't have to write the word boundaries when you're doing these problems. I'm just writing it for us right now since we're starting out. And of course then from 1 to 3. So be careful here. We're not going from 0 to 4, even though it shows from 0 to 4 here, and up here we did go from 0 to 4. Here we're going from 1 to 3. So you need to start here at the 1, draw the boundary line right there, that vertical boundary line. And then to the 3, draw that vertical boundary line in. All right, so then our region is this. Okay, that's our region right there. And what kind of shape is this shape?
It's
a trapezoid. Yes, a trapezoid.
What's the difference, true?
So how do we find the area of a trapezoid?
You could do the area. You do the area of the rectangle and then the area of the.
You could. Okay, yeah. Let's break it up. Let's do it that way. All right. So we'll break it up into 2 geometric shapes who we're more familiar with. So we do have a rectangle here and then a triangle here. So the dimensions for this rectangle are what? 2 by, yes, 2, exactly right. And now that'd be confusing to you because that does not look like a square, it looks like a rectangle, but it's the scale. The scale is different. On the bottom, each tick mark is 0.25, or sorry, on the x-axis is 0.25, on the y-axis is 0.5, so that's why it looks off. It is. All right, the scale is off. So, okay, the area of that rectangle then is 2 by 2, so 4 plus, and then the area of this triangle. Well, what's the base of the triangle? 2, and what's the height of the triangle? 2 as well. So it's going to be 1/2 times 2 times 2. So it'll just be 2. So 4 plus 2 is 6 units squared. It's just for those of you that are interested, and we'll need this for later. Actually, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. All right, base 1 times base 2. Now, in a trapezoid, and really for any shape, the base of a shape is not always its bottom side, right, however it's oriented here. The bases in the trapezoid are what 2 sides of the trapezoid?
The ones that are like parallel.
the parallel side. So that's this side is a base, this side is a base. So that would be 4 and 2. 4 plus 2 is 6. Half of that is 3, but then the height of the trapezoid is 2, so it's 3 times 2, 6. So we do end up getting the same thing using that formula. All right? Cool. All right, so this next shape, all right.
Wait, is that how you would do that? Like, that's how you, there's no, like,
No,
calculus involved?
no, yeah, no, there is, but that's how we're doing it now. And actually, there will be problems in, our, on the free response, or, potentially in, on the AP test, where you'll be using geometry to help you find some of the areas and stuff like that. So, this is why this is important. All right, so this one, can we break it up into rectangles and triangles? Yeah, not really, but what is it, though?
Half a circle.
It's a semicircle, or half of a circle. So we know the area formula for a circle is pi r squared, so then the semicircle would be 1/2 pi times the radius squared. What is the radius of the circle?
3.
Yeah, 3. So it's going to be 1/2 times pi times 3 squared. So I'm going to go ahead and just say that's 4.5 pi. I'm not going to multiply the pi through. Okay. So area under the curve again, so it's the space between the curve and the x-axis, and actually we really don't need any other, well, I guess from 0 to 6 is important, okay, but it just basically is this region right here, right? It was this region that we just found, that area. Like so, that was the region that we found. I see what you're saying. Yes, it's true. Yeah, I got you. You're right. Yeah, we just use the generic word curve. Yeah. It's generic curve. All right, 4.5 pi, and again, you can put units squared if you want to there. All right, so far so good, right? This is like geometry, basic geometry. You guys are like, I learned this in middle school, Mr. Witt. Okay, great.
Or like 4th grade, did I think?
4th grade? Okay, great. All right, this shape.
That's fine.
We want to find the area from negative 0.5 to 4.5. All right, so it looks like we want to find the area of then this region. So it is a triangle. So again, the triangle's area formula is 1/2 times base times height, which is, let's see here, what's the base of this triangle? 4. What's the height of this triangle?
No, it's 5. It's 5.
Oh, you're right. I'm sorry. No, you're right. The base is 5. Because it's the 0.5 here and then plus the 4.5 out. So it's a total of 5. Total of 5. From negative 0.5 to 4.5, that is a distance of, 5. Thank you for that catch there. The height of this triangle is 5 as well. So again, it's the scale is, actually the scale here is the same. So anyway. All right, so it's going to be then 25 divided by 2, so 12.5 units squared.
Thank you. Thank you.
And now let's do this curve.
And now it's no longer.
Uh-oh, you got it.
All right, it's back to, now it's back, Max, going to be happy here. It's back to a nice curvy curve.
I did that one a different way, so I got different.
For this one?
I
What different way did you do it?
I cut the triangle in half.
Okay. Hey, this is not wrong. Okay, so then what's the area, so you found the area of each triangle and then add them together?
Well, yeah, so I just did a box. So
Oh, you did like this? You added 2 triangles together and made like,
yeah, then it'll be the same thing.
okay, sure. What is the height of this box? 5, okay, great. And then what is the length of this box? Right here, the width, or what do you want to say?
2.
0.5. Yeah. You see what so I see what you're saying. You're like, oh, it went out to 2. That's a length of 2. But then you have to add this 0.5 on from this direction, so it's 2.5. So yes, that would work. Just make sure you watch your decimals there, like we did. We made the same mistake too, or similar mistake. Okay. Area of the curve from 1 to 5. So go ahead, shade in that region. Go ahead and identify the region, folks. Do it right now. Take 2 seconds. Okay. This is going to be part of the difficulty is identifying the correct region. So you might be like, Miss Withers, this is ridiculous. Really, I'm just going to wait and just have you do it. No, you need to try this.
So then geometry, when we have to color the different sides of the graph.
Possibly, I think. Oh no, that was actually algebra. That's inequalities. When you graph inequalities and stuff like that, that's algebra 1. Yeah. The shading.
The only thing I remember from geometry is proof after proof after proof after proof.
All I remember is angle side side. That's all. I know.
All right, you guys shaded in? All right, should look like this. Boom.
Whoa.
It might look like that.
Okay, so what is the area underneath this curve?
7.
7? How'd you get 7? Good whole number. It is.
Good old number.
It is. It's a good old number. Good whole number. Whatever you said there. So,
We don't know, Miss Subway?
we don't know, but what could we do?
Count the boxes.
Well, okay, we can break it up into pieces, right? So, for example, here we have like a nice rectangle right there, right? And then like,
I'm not drawing these lines.
no, this is what we're gonna do.
Wait, you see?
We're gonna approximate it. Yeah, we're gonna approximate.
Okay, so we're not at the integration part yet.
No, our focus right now is to approximate the area under the curve if we need to. So right now we're approximating. So we're gonna do our best effort here to try and approximate this. So we're gonna break it up into parts that we can find the area of. So the area of the rectangle it's 5. So yeah, it's 5 by 1. So 5. Oh, it's 4. Never mind. You're right. It's 4. Because you start at 1, go out to 5, so it's a distance of 4.
Oh my gosh, what's the word?
Why does it have to have like these 0.5 intervals?
Okay. So it's a bigger graph. That's why. So 4 is the area of the rectangle. All right. Let's find the area of these triangles. Let's do the smaller triangle here first. What is the base of that smaller triangle? Small triangle. Yeah, it's a base of 1. And then what's the height of that smaller triangle? Yeah, we have to like approximate here, don't we? It's like it's a little bit more than 0.5. I'm gonna say it's like point. You want to say 0.75? Let's say 0.75. Did I say that before? Oh, I said about 0.6 before, but oh well, whatever. That's fine. Okay, so 0.375. Okay, for that one. And then the big triangle, what is its base? Yeah, from 1 to 4, yeah. And then, so yeah, it's a base of 3, and its height,
It's like 4.8.
and for some, yeah, it goes from 1, so 4 is 3, and then about 1/2, sorry, thank you. So 3.6 you want to say, because yeah, 1 to 4 is 3, or 3.4 actually is what it'd be more close to. Yeah.
Oh, I drew mine over.
Yeah, 3.4. Okay, so like about 3.4, I think is what I have there. Yep, I put 3.4 last time, so that's good. Okay, when you multiply that all out, you get about 5.1.
So
again, 5.1 units squared, about 0.375 units squared, and then about, well, not about 4 units squared exactly. So all those added together, all those added together then, so 5.1 plus 0.375 plus 4 yields 9.475 units squared approximately. Okay, question, yes.
So, I did mine a little differently. I like outlined all like the whole boxes you could fit
Okay,
in the curve,
that's fine.
and like counted those up.
Yep. So yours is going to yield obviously a different answer then.
Yeah, I got
A lower answer.
I got 7 like exact whole boxes.
Right.
So
Yeah, and that's fine. Again, we're going to be exploring different ways to approximate here. So in our approximation that I did up front here, this approximation, can we say more about it? Is it an over approximation? Is it an under approximation?
Under.
So what do we? Which one? Over because why, Caleb?
Because,
Right, you can see we're counting this extra area here, using this bigger triangle, we're counting all this extra area that's not underneath the original curve. So this is going to be an over approximation the way I did it. Now, Ryan, may I show your paper? All right, so Ryan did it slightly differently than us. He decided to go for like just whole boxes like this. All right, now with Ryan's method here, is this going to be an over approximation or an under approximation? Under, and you can see because he's missing spaces. Okay. Sorry, yeah, and there's different ways you can do it, okay? So what we can say then, actually may I borrow this one more time, what we can say then is that the true area is going to be between 9.475 and 7, okay? And so that's helpful. We at least have a range now. And so in this section, we will examine the problem of finding the area of a region in the plane between a curve, okay? Sometimes between two curves, too. All right? So, we'll stop there.
Well, that's my favorite thing to hear.
Joey,